All right, this is number 3.48. It's you're trying to cross a river and you want to end up right here, which is 118 meters downstream. The river is 285 meters wide, and it says the boat is going at a 45-degree angle. And in my exam, I'll just leave it as V of the boat. Doesn't matter what the number is, VB. But it says you want to end up going here, and the question is, what does the velocity of the current have to be? So there's two ways to do this. One is the way I've been telling kids, and one student, Jessica, figured out how to do, which I think might be a lot easier. But I'll show you the hard way first, and then her easier way. So my way of looking at it was you need to find what this V resultant is right here. Because if you can figure that out, you'll know that you're on this path here, which is what you want to be on. And it's really just a vector addition problem. V of the boat plus V of the current gives you your resultant, VR. So this is tip to tail right there, and that gives you that. So what you have to do is you break it into components. V of the boat in the x is easy enough to find. VB in the x is just VB cos theta. You have all that information. You'll get that. VB in the y is that. VB in the y is just VB sine theta. Again, you have that. Now the key here is recognizing that this VB in the y right here is the same as VR in the y. So if you do that, if you say VR in the y is equal to VB sine theta, you can figure out what VR is equal to, because VR, well, let me write it this way, VR sine of this angle here, which I'll call phi, VR sine phi is equal to VRY. Now you're probably saying, well, how do I find that angle phi? That's this angle here again. You have the geometry right here, so you know what this angle is. It's the same as this angle here. So you can do tan of phi equals 285 over 118, and that'll give you the angle. Then you can plug it in. Over here, you find what VR is, based on VRY being equal to VBY. Then once you have VR, you can do VR in the x. Sorry, I'm going up here now. VR in the x equals, and that's this component right here. Yeah, my way is way more complicated. Is equal to VB in the x minus VC in the x, which VC in the x is what VC is, and that's the answer you're looking for. So you can find it doing it that way. Now, let's do it Jessica's way. She decided that you want to go 285 across and 118 down. I don't know if everybody's numbers are the same. So you want to end up here. What she said is if the boat goes at a 45-degree angle, you're going to end up downstream this far. And you can figure out what that is. You just basically do, well, if you find V boat sine theta and set that equal to delta x over delta t. Is that what she did? I don't even know if you had to find what t was. Yeah, because you have delta x and you have this. Excuse me, sorry. Again, this was her way of doing it. You can figure out what delta t is. All right, and then based on, do this for delta y. Delta y over delta t, because you know what delta y is. It's 285. And you know that VB sine theta is just going to be whatever the speed of the boat is times the sine of 45. That will tell you what delta t is. And then plug that in for, VB cosine of theta equals delta x over delta t. If you cross multiply, you get what delta x is. That's going to tell you this bigger number here. Subtract the 118 from it, and that will tell you how far upstream you are And what you need to do is say v of the current times the time will tell you what that delta x has to be. That means the current will take you back in that direction. And I think that's like 1/10 of the time it took me to explain mine. So thank Jess for that one.